So in the first set of directions, it said use substitution. Use substitution to determine whether the x value is a solution. Because the directions are going to be important. They're going to change a couple times, and you're going to need to know what they are. So those first problems that we did said use substitution to determine if x is a solution. All right, there'll be a few of those. And then the next set of solutions say find, or the next set of directions say find all the solutions. Find all the solutions. So you get to find solutions here. So here's the equation that they're asking you to solve and find the solutions. And I love this section because I'm not doing 10. How did I get to 10? I wanted to change directions. These are not the directions yet. This is one of those where it says check to see if this is a solution. Sorry. I can't read. I'm ahead of myself. Still in the same set of directions. Use substitution to check to see if x equals pi over 6 is a solution. This one's just a little bit harder because I have an x on the left and I have an x on the right. Okay, so if we plug those in, we're going to get cosine of x, and in the place of x, we're going to put in pi over 6. And then on the right-hand side, we're going to have square root of 3 times sine of another x. That's the same x, and that x is also going to be substituted in as pi over 6. So in your little minds, figure out where pi over 6 is on the unit circle. Think about what the x value is at pi over 6. What's the x value at pi over 6? Radical 3 over 2. And then the equation says add 2 to that. And then on the right-hand side, we've got to do square root of 3 times the sine at pi over 6. What's the sine value at pi over 6? 1/2. And then on the left-hand side, we're going to get square root of 3 over 2 times 2. Or excuse me, we're adding 2 here. We can't add unless we have a common denominator. So the 1 turns into a 2, and the 2 turns into a 4. And I end up with a square root of 3 plus 4 over 2. And on the right-hand side, we're multiplying, so we don't have to find a common denominator. We just do top times the top, bottom times the bottom, and we get square root of 3 over 2. So is the square root of 3 plus 4 over 2 equal to the square root of 3 over 2? No, it's not. So pi over 6 would not be a solution. So there's an example of where an x that they gave you was not a solution. All right, now we're going to change directions. Now the directions say find all these solutions. Sometimes they're going to say find the solutions between 0 and 2 pi. But these directions, this set of directions say find all, and they mean all. So underline that all. Find all solutions. Again, sometimes they'll tell you find solutions between 0 and 2 pi, or between 2 pi and negative 2 pi. And sometimes the directions will say find all of the solutions in the whole wide world. That's a lot of solutions. So let's look at number 12. All right, this is a fairly simple equation. So what it's asking you for is what angle has a cosine value of square root of 3 over 2. What angle has a cosine value of square root of 3 over 2. What you want to do is you want to think unit circle here. You want to go from 0, okay, you want to go in this direction. You want to find the first angle that you can. There's multiple angles. There's more than one angle that has a cosine value of square root of 3 over 2. But you want to find the first one that you come to starting at 0 radians. So what angle has a cosine value of square root of 3 over 2? The first one that I come to is pi over 6. Okay, because it says all solutions, okay, there's another angle that has a cosine value at square root of 3 over 2, and what is it? If we keep going. 11 pi over 6. And then technically we could keep going, okay? So we have one here, just to give you an illustration. We have another one here, and then we could just keep going, and our angles could get bigger and bigger. We could also go the other direction, and they could get smaller and smaller. So how do we write all of them? Okay, we're going to write this down because this is just for your information. Because the period of cosine, think about your graph, the period of just the cosine graph with no transformations is 2 pi. Every time you go 2 pi, you end up getting another cosine value of square root of 3 over 2. Then we're going to take that first answer, which was pi over 6, and to represent all of the angles that have a square root of 3 over 2 as their cosine value, we're going to add, we're always going to add 2n pi. And 2n pi represent every single time you start at pi over 6 and you go another 2 over pi. If n were 1, you would add 2 over pi. If n were 2, you would add 4 pi. If n were 3, you would add 6 pi. So we've got to do that to pi over 6, and we also have to do it to 11 pi over 6. So if we're at 11 pi over 6 and we rotate around another 2 pi, we get the same cosine value. If we rotate 4 pi, 6 pi, 8 pi, an even number of pi, and then we show all solutions by adding 2n pi. So if you circle those are all the solutions. Those are all the solutions. Number 14. 14 is asking you to solve tangent of an angle is equal to the square root of 3. And it's asking you to find all the solutions. So start by thinking about, on the unit circle, where is the first value that gives you a tangent value y divided by x of the square root of 3. Starting at 0 radians. At pi over 3. Okay? So we're going to say x is equal to pi over 3. Now there's another place on the unit circle where tangent is also where tangent is also square root of 3, but since, write this down, since tangent has a period of pi, then we can just take that one angle, which was pi over 3, and we can add n pi to that. N pi represents 1 pi. So if you're thinking about, hey, there's another, is there not another angle right here on the unit circle that has a tangent value of square root of 3? There is, but do you not get to that angle by adding pi to it? So if we start at pi over 3 and we add pi, we get to that angle. If we add another pi, we get back to this angle. If we add another pi, we get to this angle. If we add another pi, we get to this angle. So tangent, all you have to do is find that first angle that has a tangent value of whatever they're saying, and then you'll put plus n pi for that one. Because tangent has a period of pi. All right, let's move on to number 24. Equation will get a little bit more complicated. 7 times the cosine of theta plus 9 is equal to negative 2 times the cosine of theta. So you have to do a little bit more algebra. You're solving for the cosine of theta. You have a cosine on the left. You have a cosine on the right. You need to get those cosines together. So you're going to add 2 cosine theta either in your head or on your paper. That's going to give you 9 times the cosine of theta plus 9 is equal to 0. You're still trying to solve for the cosine of theta. You're going to subtract 9. And then you're going to divide by 9. You can skip some steps if you can. And then finally, you're going to get your little cosine all by itself. And it says the cosine of theta is equal to negative 1. Cosine of theta is equal to negative 1. So on your unit circle, you're going to find the first value that you come to that has a cosine value of negative 1. Where's that? Pi, somebody says. So that means that theta is equal to pi. Any other place on the unit circle where the cosine value is negative 1? Nope. Cosine and sine have a period of 2 pi. Sine and cosine have a period of 2 pi. Only tangent has a period of pi. So once you find that one angle, then you're going to add 2 in pi. You're going to do that to sine and cosine because every single time you add another pi, 2 over 2 pi, at 3 pi, the cosine value is at negative 1. So pi plus 2 pi is 3 pi. At 3 pi, the cosine value is negative 1. At pi plus 4 pi, which is 5 pi, the cosine value is negative 1. Sometimes you'll have 2 angles, sometimes you will not. If the angle appears on one of your axes, then you won't have more than one angle. You'll just have one angle there. Again, sine and cosine have a period of 2 pi, that's why you put plus 2 in pi. Number 26. Y'all are taking this well. This one's a little bit different. Anybody see anything that's different? I've seen some radicals before. Okay, it's got 2x, and on every other problem it just had an x, or it just had a theta, just had just the variable there. Okay, so what you have to do here is you have to realize there's a 2x there, and you'll have to do a little extra step, but just start with pi over 2 and cosine. Where on the unit circle is cosine pi over 2? First place is at pi over 4, and then the second place is at have y'all forgotten your unit circle? First place that cosine of square root 2 over 2 is pi over 4. I agree with that. And 7 pi over 4. Now this is what 2x is equal to, not x. Okay, so 2x is going to be equal to pi over 4 plus n pi or plus 2n pi? Cosine and sine, is that plus 2n pi or plus n pi? 2n pi, because cosine and sine have periods of 2 pi. So that's why we're going to have to add 2 pi every single time to get all of our answers. We also have a second equation that says 2x is equal to 7 pi over 4. And again, we're going to have to do plus 2n pi because cosine and sine have a period of 2 pi. That's going to give us all the angles. There's an infinite number of angles there. That's why you have to do plus 2n pi. 2 pi comes from sine and cosine. So we got to solve for x. So on the left hand and the right hand side, we got to divide everything by 2. And what's pi over 4 divided by 2? Pi over 8. Right? Pi over 4 divided by 2 is pi over 8. 2n pi divided by 2, the 2's will cancel, and you'll just get n pi. You'll do the same thing over on the right-hand side. You'll solve for x. You'll get x is equal to what? 7 pi over 8 plus n pi. All right, and those would be your answers if the directions said find all the solutions. But the directions actually changed here. And they say find the solutions in the interval from 0 to 2 pi. Okay, so this time they're not saying find all the solutions. So we'll add this in real quick. The directions actually say for your solutions to be between 0 and 2 pi. So we get to limit them. We don't get to write all of them. And that's what we have right here. Pi over 8 plus n pi would be all of the solutions starting at pi over 8. 7 pi over 8 plus n pi would be all the solutions. But the directions actually say let's limit these only to the answers between 0 and 2 pi. So start with your pi over 8. Okay? So we know pi over 8 is a solution. And then plus n pi means add 1 pi to that. So what's pi over 8 plus 1 pi? Start with 1 pi. That would be 9 pi over 8. Okay? And then let's add another pi. So 9 pi over 8 plus another pi over 8. That'd be 8 over 8. That would be 17 pi over 8, but I can't use 17 pi over 8 according to my directions. Why can I not use 17 pi over 8? It's more than 2 pi. So if we were in eighths, what would 2 pi be equal to? 16 pi over 8. So I can't use 17 pi over 8 because my directions say we only want the solutions between 0 and 2 pi. So I can't use that one. But I can jump over here and use 7 pi over 8. That's between 0 and 2 pi. And then I could add 1 pi to that. 7 pi over 8 plus 8 pi over 8 would be 15 pi over 8. Is that 2 pi yet? No, if I add another pi over another pi, that would be another 8/8. That would be 20/38, and that would be more than 2 pi. So you actually have 4 solutions here. You have 4 solutions. Pi over 8, 9 pi over 8, 7 pi over 8, and 15 pi over 8. The book will probably write them in order from the smallest to the largest, so they'll probably swap that 9 pi over 8 and the 7 pi over 8, but I don't care as long as you have those 4 solutions. All right, one more. Number 30. We're in the same directions where it says give solutions between 0 and 2 pi. Number 30. These equations involve multiple equations. Solve your equations on the interval from 0 to 2 pi. So we have the tangent of 3 times x. Again, I'm going to take notice that I don't just have tangent of x here, so I'll have to do a little extra step once I set the problem up and divide by 3. Is equal to the square root of 3. Now the good thing about tangent is tangent you're always going to just do one value and then you're just going to add n pi to it. Sine and cosine you'll end up with 2 values that you have to add 2 n pi to. So tangent's always a little bit easier. Okay, because tangent appears every cycle of pi. You don't have to find 2 values, you only have to find 1. So on your unit circle, where's the first angle that you come to that has a tangent value of square root of 3? Pi over 3. So you're going to say 3x is equal to pi over 3. And since tangent has a period of pi, then you're going to add n pi to all of your tangent values. To n pi, you're adding to sine and cosine, because sine and cosine have a period of 2 pi. So you haven't solved for x yet, but you're close. To solve for x, you're going to have to divide both sides by 3. And x is going to end up being pi over 9 plus, and I'm just going to leave this as n pi over 3. Divide both the terms in the top by 3. Now, to make this a little bit easier, I need a common denominator, because I'm going to have to add n pi over 3 over and over and over again. So I'm going to turn this into a 9. And if I turn that into a 9, it's really 3n pi, because 3/9 reduces to be just the 1/3. So I'm just doing this to help myself find all the angles between 0 and 2 pi. So you're going to start with pi over 9, and according to what x is equal to, you're going to add 3 pi over 9s. You're going to add one of them, then you're going to add 2 of them. So we're really adding 3 pi over 9 over and over and over again until we get to 2 pi. So pi over 9 plus 3 pi over 9 would be 4 pi over 9. Add another 3 pi over 9, that would be 7 pi over 9. Add another 3 pi over 9, that would be 10 pi over 9. Add another 3 pi over 9, that would be 13 pi over 9. Add another 3 pi over 9, that would be 16 pi over 9. Add another 3 pi over 9, that would be 19 pi over 9. But that is more than 2 pi. So you don't use that one, and you would just stop with a 16 pi over 9. Now, this probably does not make a lot of sense. Let's just be honest. So let's take one of our answers and see if we can go back into the original problem and just see if it just makes sense. So let's take the pi over 9. Let's take this first one just to try to help you make sense of this mess. And so if you go back and plug it in, you would have tangent of 3 times what? Pi over 9. And they're saying that that would be equal to square root of 3. So what is 3 times pi over 9? The 3 cancels down with a 9, and that gives me pi over 3. Is the tangent value at pi over 3 not equal to the square root of 3? Yes, it is. If you put 4 pi over 9 in, okay, just to show you, they're not asking you to check, but these don't make a lot of sense when you get all these answers. If you put 4 pi over 9 and you simplify the left-hand side, you get tangent at 4 pi over 3, because the 3 cancels down with the 9, and at 4 pi over 3, the tangent value is also square root of 3. These are a little bit harder to check because you don't have just an x, you have a 3 times x. So there are truly 1, 2, 3, 4, 5, 6 possible answers between 0 and 2 pi for this equation. All right, questions? Y'all going to have to practice some of these. These are really different. When do you add 2n pi? Let's talk about that real quick. Okay, you add 2n pi for sine and cosine. Sine and cosine will have 2 angles, okay? So you'll have an angle plus 2n pi, and then you'll have another angle plus 2n pi. When you get to tangent, to me tangent's a little bit easier. Tangent, when you do tangent, you're just going to have an angle plus what? N pi. Tangent occurs every pi, and there will just be one value on your unit circle there. All right, y'all have about 30 minutes. Start on your homework. Seems like we're caught up for once. I'll start grading your notebook quizzes while you start on your homework.